So we're going to start with some angle definitions that we're going to be using throughout our right triangle trigonometry unit. So the basis of right triangle trigonometry is anytime we have to have something at an angle, so not just a 90 degree, like a straight, you know, something that's square, it's called like vertical, horizontal. Anytime we have to figure something out at a certain angle. So what an angle is, it's the opening between two lines. So if I have a line going like this and a line going like this, where they meet is called the vertex, and the opening, a lot of times we go up from the horizontal, not always though, it all depends. Sometimes from the vertical we go a certain direction, but whatever that opening is the angle. So a lot of times I'll use capital A. So for full circle, so if I go all the way around full circle, that's 360 degrees. Straight line, so if we have, here's my vertex, if I go until I have a straight line, that's half of the 360, 180 degrees. And then a perfect vertical to a horizontal, so like this, that makes a 90 degree angle, and a lot of times we use a box in the corner like that. And throughout this unit, if it looks like a 90 degree and there's no box, usually we're going to assume that it's 90 degrees. So, and I'm kind of jumping ahead down here, but that is called a right angle. So whenever we have a 90 degree, we call that a right angle. And that's kind of, you know, this whole unit's called right triangle trigonometry. So we're going to be dealing with triangles with a 90 degree angle. And if we don't have one, a lot of times we can make a 90 degree angle, like draw a straight line straight down or across to make a 90 degree and figure some things out from there. So besides right angles, every once in a while we might use lingo that if I have something less than 90 degrees, between 0 and 90, so something like this, that's called an acute angle. And then once we go over 90 degrees, something like this, that's called an obtuse angle. And this is going to be something we use quite often. All the angles of a triangle. We have a triangle. I'm going to label this A, B, C. All of those would add up to 180. Okay, so it's almost even like a little equation here. A plus B plus C is always going to equal 180. So we'll use that in the next one, that idea. So in our first example here, find the missing angle of this triangle. So 35, 35, and whatever, I'll call that A, should add up to 180. So if we know two of the angles, what I can do is just do 180, take off the other two. So whatever's left should be my angle A. So this is going to be 110 degrees. And I kind of just did that in my head without my calculator because I thought 35 and 35 is 70. Yep, that's 70. 180 minus 70 is 110. So that's another, you can add up the other two, subtract it from 180. That'd be the same thing as doing 180 minus 35 minus 35. Okay, now the next one, we have a bolt hole circle and it has 8 circles around it. How far apart are the holes? So in degrees. So we're talking about right here between each consecutive hole, what would that angle be? So since this is all the way around 360, we're splitting it into 8 sections. Take 360 divided by 8 to get 45 degrees. Notice too how when I cut straight across and straight up, it does make a 90 degree angle, particularly just because this is 8 circles. If it's 9, obviously it's going to be a little off. Different number of holes would be different, but in this case, we end up with 90 degrees between two of them, cut that in half. Half of 90 is 45. Okay, now a couple more angle definitions, and this can come in handy if you're laying something out that you might know the angle in one spot. You can a lot of times use these definitions that we've been going over to figure out the angles in other spots. So like this one, 25 is that angle on the right side. Well, I could figure out that N is going to be whatever 180 minus 25 is, because that makes a straight line. See, right here is a straight line 180. So 180 minus 25 is 155. And then same idea with the m and the n, those should add up to 180. So 180 minus 155, that goes back to 25. Same idea down here, p would be 155. So notice, kind of up above in the definitions, vertical angles are what we call angles that are opposite, and they're always going to be equal. So notice how the 25 and the m are equal, and then the n and p would always be equal. And that'll always be the case if you're talking about two lines intersecting. Going a step further, if I have parallel lines, so right here, these two are parallel, meaning that they never intersect. They're both exactly horizontal in this case. But anytime it's two parallel lines and you have a line that cuts through those, it's called a transversal. We have these corresponding angles that happen. Okay, so if this is 55 right here, the corresponding angle down below is that top right spot. That is also going to be 55. And then the vertical angles, the ones kind of kitty corner from each other, 55 down here, 55 down here. Those would all be the same. So this can come in handy too if like you're trying to get at something, you can't measure the angle somewhere in a different spot, but you can measure it, take some sort of straight edge and use that. So then all the other ones, well, this has got to be 180 minus 55. So that should be 125. And then all these obtuse angles would be 125 because they're all corresponding to the other spots.